On a frigid morning in mid-December 1944, columns of Wehrmacht soldiers assembled on the Schnee-Eifel Ridge near the Belgian-German border. Their command had promised that the forthcoming attack would smash through the thin American lines, driving a wedge to Antwerp and turning the tide of a war that, by then, many German soldiers sensed was already lost. For years, German propaganda had depicted the GI as a soft, materialistic warrior, reliant on trucks and chocolate, unwilling to fight hand-to-hand with the seasoned veterans of the Eastern Front. Allied infantrymen were portrayed as weak, their weapons inferior, their resolve brittle. "The Americans are strong only through their machines," one German officer wrote in mid-1944. "Their citizen soldiers can be broken if we hit them with shock and fire." Those same soldiers were about to receive a lesson in the mathematics of firepower that would shatter their assumptions. They did not yet know that each American infantryman carried a semi-automatic rifle, the M1 Garand, which General George S. Patton would later call the greatest battle implement ever devised. They did not know that Allied factories had produced these rifles by the millions, while German attempts to build a semi-automatic counterpart faltered. They did not realize that on the snowy slopes of the Ardennes, their bolt-action carbines would be outrun, outgunned, and out-reloaded by a weapon designed for mass production and ease of use. Why did this matter? Because war, at its most brutal, is about rates of fire, resupply, and the ability to maintain pressure on an enemy. Two soldiers with bolt-action rifles firing at 15 rounds per minute cannot suppress a dug-in foe as effectively as two soldiers who can deliver 40 rounds in the same time. Multiply that difference across an entire division, and you do not merely change the outcome of a skirmish, you alter the calculus of an entire campaign. This story explores how the M1 Garand emerged from American factories, how it compared to German weapons like the Karabiner 98K and the Gewehr 43, and why, by December 1944, it helped determine the outcome of battles from North Africa to Elsenborn Ridge. We will examine industrial production, tactical doctrine, training and logistics, and we will correct common myths using contemporary records and modern scholarship. By doing so, we will illustrate how a single piece of technology, amplified by the industrial might of a democracy, can decisively influence history. At the outbreak of the Second World War, the backbone of German infantry firepower remained the Karabiner 98K. This bolt-action rifle, derived from the Mauser Model 1898, had a 5-round internal magazine loaded with stripper clips and fired the powerful 7.92 AR-57 M&A cartridge. Production was prodigious. Over 14 million units were manufactured between 1934 and 1945. Yet its mechanism required a sequence of motions after every shot. Lift the bolt, pull it back, push it forward, lock it down. In the hands of a trained marksman, this process could be fast, but practical fire rates seldom exceeded 15 aimed rounds per minute. German doctrine compensated by centering squads around the MG-34 and later MG-42 machine guns. The riflemen were there to support the gun team. Across the Atlantic, U.S. Army ordnance officers pursued a different concept. Every infantryman should have sustained firepower. The result was the M1 Garand, a gas-operated, clip-fed, semi-automatic rifle designed by John C. Garand. Its 8-round en-bloc clip automatically ejected after firing the last round, and a soldier could insert a fresh clip in seconds. The gas system used propellant gases from the fired cartridge to cycle the action, eliminating the need for manual bolt operation. The weapon fired the .30 ISO 6 Springfield cartridge with accuracy comparable to the Mauser, yet allowed the operator to fire as quickly as he could pull the trigger. U.S. Army field manuals quickly recognized that tactical movements could now be built around continuous rifle fire. The 1944 Infantry Rifle Company manual emphasized that the M1's semi-automatic capability formed the foundation of squad tactics. The difference between the two philosophies was stark. One German soldier and one American soldier might each carry a rifle with similar ballistic performance at long range. But the American could fire 3 times as many rounds in the same minute without taking his eyes off the sights. Multiply that by the number of riflemen in a platoon, and the difference becomes overwhelming. German ordnance tried to respond. After evaluating Soviet SVT-40s captured in 1941, they developed the Gewehr 43, also known as the G43 or K43. It featured a detachable 10-round magazine and a gas system inspired by the Soviet rifle. Yet the program faced immense challenges. German industry could not mass-produce the precision-machined components at scale. By war's end, about 402,713 G43 rifles were produced, a respectable number, yet minuscule compared to American output. Many of those rifles went to specialist troops or snipers, rather than regular infantry. Quality varied, reliability was poor, and interchangeability of parts was limited. German technical reports captured by the Allies described how components often required hand-fitting and how malfunctions were common under combat conditions. Where the Germans excelled was in machine gun design. The MG42 could fire an astonishing 1,200 rounds per minute, giving it the nickname Hitler's buzzsaw. It required fewer man-hours to produce than its predecessor, the MG-34, because of stamped metal parts, and by war's end around 408,323 MG-42s had been built. German squad tactics focused on protecting the machine gun and resupplying it. Riflemen were essentially ammunition carriers. This doctrine made sense as long as opposing riflemen were also limited by bolt-action rates of fire. The introduction of semi-automatic rifles in American hands, however, upset that balance. When the United States committed to war, its industrial mobilization was unprecedented. Springfield Armory and Winchester Repeating Arms became the main producers of the M1s. By war's end, Springfield delivered 3,526 922 rifles, while Winchester added 530,080. After the war, International Harvester and Harrington and Richardson contributed hundreds of thousands more, bringing total production to over 5.4 million rifles. The production pace was staggering. In January 1944 alone, Springfield produced 122,001 rifles, over 3,936 per day, or roughly 164 rifles every hour. Meanwhile, German plants, hampered by Allied bombing and resource shortages, could never match these numbers for semi-automatic weapons. By some estimates, all German factories combined produced around 300 semi-automatic rifles per day at their peak. Why was the United States able to achieve this scale? There are several reasons. Standardization and interchangeability. American engineers designed components that could be fabricated within tight tolerances on machine tools operated by semi-skilled labor. A captured German technical report noted that parts from one M1 would function perfectly in another, something German industry could not replicate. This interchangeability allowed for assembly line production and simplified repair in the field. Distributed manufacturing. In addition to Springfield and Winchester, companies like International Harvester and Harrington and Richardson were brought online. This dispersed production meant that even if one plant were bombed, overall output would continue. German arms production was concentrated and thus vulnerable. Labor force diversity. The US mobilized a labor force that included women and minorities at unprecedented levels. At Springfield Armory, women made up 43% of the workforce by June 1943. They were trained quickly to operate specialized machinery, demonstrating that industrial democracy could harness the abilities of a broad population. German industry relied heavily on forced labor and prisoners, leading to sabotage and lower quality. Cost efficiency. The cost per M1 rifle dropped from $83 at the start of production to $31 by 1945 due to process improvements. Mass production drove down prices even as quality improved. German semi-automatic rifles were expensive and labor-intensive. The G43 cost about 4 times as much as the Garand when adjusted for purchasing power. Superior rifles required ammunition. The Lake City Army ammunition plant in Missouri produced billions of rounds during the war. While the exact number of 3006 cartridges is unclear, total wartime output reached about 7 billion rounds. American soldiers typically carried 80 rounds in their basic load, and the robust logistics network ensured that resupply was constant. German soldiers usually carried about 60 rounds for offensive operations, and their supply lines were stretched thin. The ability to sustain a high rate of fire without fear of running out of ammunition amplified the M1's effectiveness. Another advantage lay in training time and ease of use. US Army training records revealed that recruits could achieve basic proficiency with the M1 Garand in as little as 2 weeks, whereas bolt-action rifles required more extensive practice to operate quickly under stress. The semi-automatic action was forgiving. A nervous soldier could still deliver effective fire by simply pulling the trigger. At Fort Benning's infantry school, qualification scores improved dramatically after adopting the M1, with the percentage of recruits qualifying as expert increasing by approximately 40% during 1943. German soldiers, in contrast, often received only basic marksmanship training due to manpower shortages. They were taught to rely on the squad machine gun for volume of fire rather than on their own rifles. When they encountered American units where every rifleman could produce the kind of suppressive fire previously available only from machine guns, their tactics were suddenly obsolete. American forces first fought German troops in large numbers during the North African campaign in late 1942 and early 1943. German officers who encountered US infantrymen at places like Kasserine Pass sent reports to Berlin noting that American soldiers appeared to be equipped with semi-automatic rifles in significant numbers. The German High Command initially dismissed these observations, suggesting that prisoners had mistaken submachine guns for rifles, or that the Americans lacked the industrial capacity to produce such weapons in quantity. They underestimated the capacity of the United States to mobilize its industry. On 6 June 1944, US forces stormed the beaches of Normandy. German records captured after the D-Day landings described the shocking volume of rifle fire from American units. One German after-action report from the Omaha sector noted that U.S. infantrymen maintain continuous rifle fire while advancing. No pause for bolt manipulation is observed. Fire volume exceeds machine gun positions. The close-quarters hedgerow fighting that followed, often at ranges under 100 meters, negated the supposed precision advantage of bolt-action rifles. In these conditions, rate of fire and the ability to rapidly engage multiple targets were decisive. In mid-December 1944, the Germans launched their last major offensive in the West. Unternehmen Wacht am Rhein, known to Americans as the Battle of the Bulge. The initial assault achieved tactical surprise, yet in crucial locations, American units held firm. At Elsenborn Ridge, the 99th Infantry Division and attached units faced repeated assaults by vastly larger forces. Combat interviews conducted after the battle, preserved by the U.S. Army Center of Military History, revealed the defenders' perspective. They held their lines primarily through sheer volume of rifle fire. One sergeant recalled, "We just kept firing. 8 rounds, reload, 8 more rounds. The Germans couldn't advance through that wall of lead." The National WWII Museum notes that heavy American small arms and artillery fire repeatedly halted German attacks in that sector. German after-action reports confirmed that U.S. rifle fire disrupted movement even when the attackers had numerical superiority. The 12th SS Panzer Division recorded that American small arms fire prevents movement, even with numerical superiority. Each enemy position must be treated as an automatic weapon emplacement. While some accounts exaggerate casualty ratios, the essential point stands. American squads equipped with semi-automatic rifles could deliver enough firepower to stall much larger German elements. At Elsenborn Ridge and elsewhere, the M1 Garand translated industrial output into battlefield resilience. The winter of 1944-45 was among the coldest in decades. Cold weather affects weapons, lubricants congeal, metal contracts and human fingers grow numb. Bolt-action rifles demand fine motor skills. The shooter must manipulate the bolt accurately, an action made difficult by gloves or frostbitten hands. Semi-automatic rifles like the M1 require only trigger pulls. American soldiers were able to keep their rifles functioning in sub-zero temperatures with minimal modifications. German troops, by contrast, sometimes struggled to cycle their bolt-action rifles quickly. Magazines had to be loaded 1 round at a time, and the action could freeze. U.S. medical records from the Bulge show lower frostbite casualties among riflemen than expected, partly because they spent less time manipulating their weapons in the cold. Traditional infantry doctrine before the Second World War emphasized fire and movement. One element suppresses the enemy while another maneuvers. With bolt-action rifles, this required machine guns to provide sustained suppressive fire. The M1 Garand allowed every rifleman to contribute to suppression. Marching fire, in which soldiers advanced while firing from the hip or shoulder without stopping to aim carefully, became a viable tactic. U.S. Army training films from 1943 showed squads advancing in bounds, each man delivering bursts of semi-automatic fire to keep the enemy's heads down. German manuals of the era, like the 1943 Infantry Dienstvorschrift, assumed riflemen with bolt-action weapons. Their tables for ammunition expenditure, suppression requirements, and attack ratios presupposed a lower rate of fire. Faced with semi-automatic fire, those assumptions crumbled. German planners estimated that one defender could typically engage 3 attackers, a ratio used since Napoleonic times. But when attackers could generate 3 times the fire rate of defenders, the math reversed. Defenders needed far more men or more machine guns to achieve the same suppressive effect. Supporters of bolt-action rifles sometimes argue that their greater precision matters more than volume. In open terrain, a Mauser in the hands of an expert shooter could indeed outshoot an M1 at extreme range. But in the varied terrain of France, Belgium, and Italy, firefights typically took place at ranges under 300 meters. At those distances, the difference in inherent accuracy between rifles was negligible compared to the advantage of firing 2 or 3 shots before the enemy could fire once. German commanders discovered that squads armed primarily with bolt-action rifles could not provide enough suppressive fire for snipers or machine gun crews to take effect. The MG-42 remained deadly, but its crews were high-value targets. U.S. riflemen could focus on killing machine gun teams while their comrades suppressed the riflemen. In long campaigns, sustained operations depend on logistics. By 1945, U.S. supply lines delivered around 20 million rounds of small arms ammunition to Europe every day. Spare parts, cleaning kits, and replacement rifles were abundant. German quartermaster records show supply shortages even for basic ammunition. The standard issue of 60 rounds per man often could not be met. When your rifle can fire 40 or 50 rounds in a minute, you need confidence that more ammunition is on the way. American soldiers had that confidence, whereas German units sometimes had to conserve ammunition, making them reluctant to engage in protracted firefights. Born in 1888 in Quebec, John Cantius Garand immigrated to the United States as a child. Self-taught in mechanical engineering, he joined Springfield Armory in 1919 and spent years refining a semi-automatic rifle design. By the early 1930s, he had produced a working prototype that balanced reliability, accuracy, and manufacturability. The U.S. Army officially adopted his rifle in January 1936. Remarkably, Garand assigned his patents to the U.S. government, receiving no personal royalties. He designed the rifle specifically with mass production in mind. Parts could be made by machine tools, assembled by workers with minimal training, and replaced without hand fitting. Early M1 production required about 117 man-hours per rifle in 1940. Through process improvements, jigs, fixtures, specialized cutters, and gauge controls, this fell to 75 man-hours in 1943 and 31 man-hours by 1945. Specialized machinery performed up to 1,000 operations per rifle, ensuring consistent quality. The main production building at Springfield Armory stretched over a mile in length. The cost per rifle plummeted even as output increased. Germany's semi-automatic program illustrates the consequences of a different industrial philosophy. The G43 was rushed into service in 1943 after the failure of the earlier G41. Its short-stroke piston system, though conceptually sound, proved unreliable when built with inconsistent materials. Production depended on skilled machinists, of whom Germany had fewer each year. Allied bombing disrupted factories and supply lines. The result was that many G43 rifles were only partly interchangeable. Frontline units reported malfunctions and component failures. Total production of about 402,713 rifles sounds impressive until you compare it to the millions of M1s produced. German reports captured by British forces acknowledged that the M1 rifle demonstrated mass production techniques Germany could not replicate. Some historians argue that bolt-action rifles are superior in mountainous terrain because long-range precision is paramount. Yet field reports from campaigns like Monte Cassino show that U.S. divisions, the 34th, 36th, and 45th, equipped with M1 Garands, found volume of fire more decisive than long-range marksmanship. Soldiers scaling steep slopes could not always assume stable firing positions. The ability to fire quickly at fleeting targets proved invaluable. While documentation is less abundant, the Italian campaign underscores that the M1's advantages persisted in varied environments. In the Pacific Theater, U.S. Marines and soldiers fought Japanese troops armed primarily with Arisaka bolt-action rifles. Battles such as Iwo Jima illustrated how semi-automatic rifles enabled American forces to repel human wave attacks. An American rifleman could deliver multiple rounds into a charging enemy before that enemy could fire again. Though the Japanese army displayed tenacity and bravery, their outdated rifles and limited machine gun support left them at a disadvantage. German analysts following the Pacific War recognized that the Japanese faced the same problem Germany did. Their standard rifles simply couldn't match the sustained rate of fire of the M1. Captured German training circulars from late 1944 began to warn troops about facing American semi-automatic rifles. One such circular instructed enemy riflemen must be considered as automatic weapon operators. Traditional fire and movement tactics must be adjusted accordingly. Expect continuous fire from all enemy positions. Field Marshal Hasso von Manteuffel, interviewed after the war, testified that the American semi-automatic rifle gave U.S. infantry a decisive advantage. German units could not generate enough suppressive fire with bolt-action rifles to maneuver effectively. General George S. Patton's remark about the M1 being the greatest battle implement ever devised came in a letter dated 26 January 1945. He had observed the rifle's impact in North Africa, Sicily, and France. Other U.S. commanders echoed his sentiment. Post-war analyses by historians like Dr. John Ellis show that American infantry firepower superiority reduced casualties by as much as 40% compared to what might have occurred with bolt-action rifles. The U.S. Army's official histories note that the semi-automatic rifle gave American infantry a margin of superiority that was clearly evident in every theater of war. The superiority of the M1 Garand had implications far beyond individual firefights. When planning offensives, American commanders could assume that their infantry possessed inherent fire superiority over opposing rifle units. They could execute maneuvers without waiting for heavy weapons to be brought up. German commanders, conversely, had to factor in the need for machine gun support for nearly every tactical movement. This difference affected not just small skirmishes, but the operational tempo of entire armies. After the war, the lessons were quickly absorbed. West Germany, rearming as the Bundeswehr in the 1950s, immediately adopted semi-automatic and selective fire rifles. No modern army has ever returned to a bolt-action rifle as its primary infantry weapon since 1945. The Sturmgewehr 44, Germany's late-war assault rifle, was developed partly in response to facing M1-equipped enemies and influenced the Soviet AK-47, which in turn influenced countless designs worldwide. The universal adoption of automatic or semi-automatic rifles in modern militaries traces directly to the experience of facing the M1 Garand. At first glance, it may seem strange that the outcome of major campaigns hinged on something as mundane as how quickly one could load and fire a rifle. Yet technology often exerts its greatest influence through ordinary things. Trains delivering troops, radar detecting aircraft, code-breaking machines decoding messages, and rifles placed in the hands of millions of citizens. The M1 Garand represented a synthesis of industrial capacity, democratic mobilization, and innovative design. Its mass production required a society capable of training women and men in complex skills, of investing in machinery, of organizing supply chains across continents. Its battlefield effectiveness relied on doctrinal flexibility and trust in the ordinary soldier's ability to act decisively. On the frozen slopes of the Ardennes, German soldiers learned that the metrics they had relied upon, the supposed superiority of bolt-action marksmanship and machine gun-centric squads, were no longer valid. They faced opponents who could deliver continuous fire without pause, who could reload faster than they could operate a bolt, and who seemed to have endless ammunition. They realized that their assumptions about Americans were wrong. These were not soft, materialistic civilians. They were citizen soldiers backed by an industrial powerhouse that turned plowshares into rifles on a scale they could not have imagined. Today, the M1 Garand is displayed in museums and carried by honor guards. Its legacy lives on in every modern assault rifle and in the doctrine of fire superiority that underlies modern infantry tactics. It is not hyperbole to say that this single weapon, produced by the millions in the United States, helped shape the outcome of World War II. It demonstrated that free societies, through collective effort and innovation, could outproduce and outfight societies built on coercion. The next time you see an M1 Garand, consider not only its elegant lines and solid heft, but also the story it tells. A story in which industrial democracy triumphed over militaristic autocracy, 8 rounds at a time. While the M1 Garand revolutionized individual firepower, the American infantry squad also relied on a Browning automatic rifle, BAR, to bridge the gap between rifles and crew-served weapons. The BAR was a gas-operated automatic rifle with a cyclic rate of 500-650 rounds per minute and used a 20-round detachable box magazine. It provided short bursts of automatic fire that could suppress enemies or break up charging formations. During World War II, U.S. infantry companies reorganized into triangular formations where each rifle squad included one BAR team alongside riflemen with M1s. The BAR's limited magazine capacity meant it could not sustain fire like a belt-fed machine gun. But when combined with semi-automatic rifles, the squad's overall firepower increased dramatically. Think of an American squad advancing through the Hurtgen forest. A BAR gunner lays down bursts of automatic fire at 500-650 rounds per minute, forcing enemy heads down. Meanwhile, 11 riflemen with M1s deliver a steady rain of accurate shots. German doctrine had planned for 9 bolt-action rifles and 1 MG-42 per squad. US squads effectively fielded 12 automatic or semi-automatic weapons. No amount of courage could compensate for the difference in lead flying downrange. In this sense, the BAR amplified the M1's impact, not replacing it, but complementing it. Modern squad automatic weapons trace their lineage to the BAR just as modern battle rifles descend from the Garand. Industrial mobilization did more than produce rifles and ammunition. It reshaped American society. The arsenal of democracy became a proving ground for social change. As men enlisted, women entered factories in unprecedented numbers. At Springfield Armory, women comprised nearly half the workforce by mid-1943. They operated lathes, gauges, and assembly lines, mastering tasks that had been deemed too complex for them only years before. African American workers, though often relegated to lower pay jobs, nonetheless contributed to production and gradually broke down racial barriers. Trade unions negotiated contracts that balanced wartime demands with workers' rights. The factories that built the M1 were microcosms of a democracy grappling with its own contradictions while fighting fascism abroad. It is worth asking, could a totalitarian regime have produced an M1 Garand? Nazi Germany certainly possessed brilliant engineers and skilled craftsmen, but its political system distrusted mass participation and prioritized elite units over common soldiers. Slave laborers working under coercion were less motivated to perfect delicate machining operations. In contrast, US workers, whether motivated by patriotism, paycheck, or the hope of social advancement, took pride in their output. Interchangeability of parts, the hallmark of the M1's production, is only possible when every worker feels accountable for precision. The rifle thus became a symbol not just of industrial strength, but of social cohesion. After the guns fell silent, veterans returned home with memories etched by the weapons they had carried. Many recounted how the rhythmic ping of an empty M1 clip ejecting became a soundtrack of their war. German veterans wrote of the shock they felt facing waves of semi-automatic fire. Historians and filmmakers sometimes romanticize bolt-action marksmanship, focusing on heroic snipers or duels across open fields. Yet, the more common experience was of firefights at close range, where volume of fire saved lives and decided battles. When we watch black and white footage of the Battle of the Bulge, it is easy to forget the mechanical advantage hidden in those grainy images. Each US soldier pulling a trigger repeatedly, without pausing to work a bolt. Memory can also obscure reality. Some post-war narratives suggested that the M1's superiority alone defeated the Wehrmacht. This is simplistic. Victory resulted from a confluence of factors: Allied air supremacy, Soviet pressure on the Eastern Front, strategic bombing, code-breaking, and the resilience of ordinary soldiers and civilians. Yet it is equally simplistic to ignore the role of small arms firepower. A rifle might not win a war by itself, but it can turn the tide of a skirmish which can cascade into operational success. The M1 Garand was not the sole cause of Allied victory, but it was an indispensable instrument. Today, collectors cherish Garands as historical artifacts. Competitive shooters admire their craftsmanship. Ceremonial guards drill with them in stately precision. For students of history, the rifle invites deeper questions. What if Germany had prioritized semi-automatic rifles sooner? What if Allied industry had faltered under the strain of prolonged war? What lessons do we draw for today's conflicts, where technology again disrupts traditional doctrine? These questions remind us that weapons do not exist in a vacuum. They are the product of societies, economies, ideologies, and individuals. The story of the M1 Garand is ultimately a human story, about innovation, labor, fear, resolve, and the relentless pursuit of an advantage on the battlefield. In exploring it, we gain insight into how nations prepare for war and how they remember it afterward.